Select the best reagent or best series of reagents to accomplish the following transformation. So when approaching a multi-step synthesis like this, we want to take a look at what we're starting with and what we are forming. So we see that our starting material is an aldehyde, and our product contains an alcohol and an amine. So we always want to examine the functional groups. We also want to take a look at the carbon chain to see if we formed any new carbon-carbon bonds. So if we're keeping track of our carbons, and I'm numbering not for IUPAC, just for keeping track of carbons. So I can see there's 6 carbon atoms. So I can see here they are again. And so I know that that carbon 6 is this carbon because I see that bond to oxygen still. And then hopefully you can see what we've added. We've added a 7th carbon atom and a nitrogen. So we have added carbon and nitrogen. So this should lead you to think about using a cyanide ion, because this is a good nucleophile. All right, and so this is a nucleophile, and that's good because this carbon atom of our aldehyde is an electrophile. So if we're able to add that cyanide ion in the first step, then we can, then it will react with that aldehyde. So if I have some kind of source of a cyanide ion, I can envision this adding to this aldehyde carbon and pushing these electrons up onto the oxygen. So I would have an alkoxide, and I would have added the cyano group. And then as long as I had some kind of proton source around, then I could protonate this to make the alcohol. And that would add our carbon and our nitrogen. So we just need some sort of source of cyanide ion and maybe a little bit of acid. So I can see conditions A and D seem to have that in the first step. And where they differ is in that last step. So when I take a look at what we are doing here, we're going from that cyanide group to the amine. We are adding hydrogen. We need to add hydrogen. And we can see that because this is going from a carbon with no hydrogens to, if you look at carbon number 7, you've got 2 hydrogens. So you've added 2 hydrogens there and 2 hydrogens there. So we need a hydrogenation reaction. So the hydrogenation conditions that we use with the cyano group is hydrogen gas, and we use that more reactive Raney nickel catalyst. And so that is option A. So the conditions for forming this is called a cyanohydrin. You may see slightly different conditions in different textbooks, but what you're going to see in common is some source of cyanide ion, some source of acid. So it might be, say, KCN and HCl, or it might say hydrocyanic acid, but it's going to have some source of cyanide ion and a little bit of acid to do that reaction. Okay, and the only other set of conditions that are close is here in D. And what would happen in D is this would do hydrolysis of the cyano group. So if you had this, let's say RCN, so instead of that amino alcohol as a product, you would end up with the hydroxycarboxylic acid. So this would be the product of D, where your cyano group, this was where the CN triple bond was, would be hydrolyzed to give you the carboxylic acid.